Due to the standards of Mode 3 normal chargers, they are not equipped with a function to identify which EV is connected to which charger. The lack of this function has hindered the creation of various charging services such as low-carbon charging options. The modulated charging current, developed by the University of Tokyo, actively changes the charging current, and it also acquires and compares the current patterns on the EV side and the charger side. By doing that, it confirms the match between EV and charger and it determines their connection status. We have recently conducted a demonstration experiment of this technology and would like to introduce it here. Experimental setup. In this experiment, one EV was connected to a charger in Shinagawa and another EV was connected to a charger in Kamaba. The manufacturers of the chargers and of EVs are different from each other. The following is a description of the process of identification of the connection between EV and charger. In the first step, target EVs and chargers are identified. This avoids unnecessary computational processing and reduces investment in computer resources. In the second step, a modulated charging current is applied to the identified EVs and chargers, and a connection is identified. This is an example of the management screen of the charger used in the experiment. In this screen, we can see that the experimental charger CHG2002 is connected to an EV. Next, EVs to which the charging plug are connected are identified. Here is the display inside the vehicle of the EV used in the experiment. This is the display inside the vehicle of the EV that is charging. It can be seen that the EV is charging. The current values obtained in the experiment are shown. By checking the matching of these four patterns of current change, the combination of connections between two chargers and two EVs can be identified. The matching sequence is performed in this experiment using the cosine similarity method. Various methods or combinations of methods can be applied to perform the matching sequence. The output of the matching sequence is shown below. Charger 1001 was correctly identified to be connected to EV 10002, and charger 2002 was correctly identified to be connected to EV 20010. EV charging is not always done by the providers of the charging service. A typical case is basic charging at home using the Mode 2 method. In such cases, the matching sequence should not be identified as connected. We have recently conducted an experiment on such a case. Here are the results of the identification process. No data are available for charger 2002 because there is no current. Also, the current of the EV 10002 is constant, so we know that it is not a modulated charging current. From these results, it can be judged that EV 10002 is not connected to the charger of the charging service provider. From the perspective of charging service providers, EVs connected to its chargers are not necessarily its customers. If an EV that is not their customer is connected to the charger, it must be detected, and charging should be stopped. The following is the result of the matching sequence. Current is flowing to charger 2002, but there is no EV that matches this pattern. Therefore, the provider judges that the EV connected to charger 2002 does not belong to its customer and stop charging it. In this way, the modulated charging current technology can correctly identify the connection status of EVs and chargers.